When trying to determine the rule for any function, we probably need one piece of information for each unknown that we need. So we can see up the top here that ax squared form is just going to be a turning point at the origin. We've got our turning point form here, so we've got our 0.23, and we've got our intercept form just here. So really, they're the three main forms. If we come down to example 18, that's really just some CAS calculator practice for you, but we can see from all of these, x is a common factor, which means we're going to have intercepts for each of these. If I take a negative 2x out the front there, we can have an x minus 2. So all of these through the origin and one other point, aren't they? So as long as you remember just the basic rules, negative out the front, 0.2. Okay, obviously now to find turning points if we need them, we can halve the intercepts or half the distance between the intercepts and find our turning point. We can complete the square, minus b on 2a, there's a whole range of different things. If we have to determine our rule, general guideline, if we're looking for one unknown, we need one piece of information. We need some intercepts. And if you've been given a rule, normally the form of the rule or the form of the equation that you have, it best governs what approach that we take. So let's have a look at example 19. So we've got a quadratic rule just in the form ax squared. Okay, so we've got one piece of information. So we're told that it goes through the point 318, which means 318 has to satisfy the equation. There's my x value, there's my y value. So what we're really saying here is that 18 is equal to some a times x squared. So 18 is equal to 9a, therefore a is equal to 2. So in actual fact, the equation is y equals 2x squared. So that's a fairly straightforward example. Let's have a look. It has a turning point and passes through. So we know straight away we've been told it has a turning point. So the turning point form is in that form there, and it goes through the 0.23. So that means y is equal to some a x minus 2 minus 3. So there's the general form of it. The other point we've got there, 3,6, helps us determine the a factor or the dilation factor. So again, x, y. So we've got 6 is equal to some a times x minus 2 all squared minus 3. Solve for a, so take 3 across. A times 1, so a is in fact 9. So the equation of our parabola is that. So the key really will be to always remember to have that a term if you have to put it in. This time I've got intercepts. So my intercept form, again, a has to be at the front. And it doesn't really matter what constants we use, okay? But we do know that if we have intercepts at -1 and 2, it means we have x plus 1 and x minus 2. So again, we need one more piece of information. Again, 3,6. 6 is equal to some a, x is 3. So we've got 6 is equal to a times 4 times 1. So 6 is equal to 4a, a is equal to, which is 3 on 2. So again, y is 3 on 2, x plus 1, x minus 2. So it's just going with whatever information you've got. Final example, we've just got 3 random points. So we really do need to probably use our calculator here. So we set up 3 equations. So the general rule, y equals ax squared plus bx plus c, and we have to substitute all 3 points in. So don't forget x, y each time. So with point 1, y is -1, and x is -2. So a -2 squared plus b times -2 plus c. Make sure you put the values in brackets. So equation 2, we substitute the second point. So y is 2, x is 1, b times 1 plus c. Equation 3, got the point 3, -16, a times 3 squared plus b times 3 plus c. So all of these give me 3 equations. I get -1 is equal to 4a minus 2b plus c. 2 is equal to a plus b plus c. And -16 is equal to 9a plus 3b plus c. So there's my 3 equations. Now, typically we'd solve these on CAS. If we had to solve manually, it's unlikely that we'd have to solve these manually. But the process to solve manually, this equation here means, if I rearrange it, it means that C is equal to -16 minus 9a minus 3b. So I can substitute that into there and that into there. So that means equation 1 becomes -1 is equal to 4a minus 2b plus whatever c is. And c is -16 minus 9a minus 3b. And equation 2 becomes 2 is equal to a plus b plus whatever c is. -16 minus 9a minus 3b. So now all of a sudden I've got 2 equations and 2 unknowns. So equation 1, 16 across makes it 15 is equal to 4a minus 9a is -5a. -2b minus 3b is -5b. Equation 2 becomes -16 across. A minus 9a is -8a. A minus 3b is -2b. So we can solve these simultaneously. Maybe if we cancel down each one first, divide by 5, I get 3 is equal to minus a minus b. And divide by 2, I get 9 is equal to -4a minus b. So let's subtract these 2 equations. Let's just get another pen. So if that's 2 and that's 1, let's do 2 minus 1. 9 minus 3 is 6. Minus 4 minus a is a plus, so it's -3a. Minus b minus b is 0. So that gives me a is equal to -2. Maybe substitute that into there. And that means we get 3 is equal to minus -2 minus b. So that's plus minus. So 3 minus 2 equals b. So b is equal to 1. So we've got 1 value, 2 values. Let's substitute both of those into there. And we've got c is equal to -16 minus 9 times -2 minus 3 times 1. C is equal to -16 plus 8a minus 3, which equals -1. So there's our 3 values. But again, really highlight, this is really a CAS question.